Solving radical equations and inequalities part 2. So we're up to example 4, solving an equation with two radicals. So you can see that both sides has a square root, and you can square the entire thing and solve this algebraically. When you do that, you're going to have a binomial. You've got a radical plus 1. This represents two things here. When you have a plus or minus, this is a binomial. Even though there's a binomial underneath the radical, we look at these two terms as a binomial. So when you square it, you're going to have that middle term. So a lot of times students miss that even when it's something simpler than with radicals. So the easiest way to solve this would be to do it with your calculator. So we can set each equation equal to 0 and solve this and then find the intersection point. So that's the way I'm going to show you guys how to do it, because that is the most practical and that would be the quickest way to find the correct answer here. So let's go to y equals. Let's clear everything out. And then the left side will go in y1. So I'm going to put the square root of x plus 2 and then plus 1. All right, make sure the plus 1 is outside of the radical or you will get a different graph. All right, and the right side will go on the y2. So do second square root, and we're going to have 3 minus x. And then we can hit graph. And the point where they intersect would be the solution. So you can see that they intersect right in here. So we can do second trace. And let's find the intersection point. For number 5 is intersection point. We have to scroll. It says first curve, but we have to scroll to the left of the point we're trying to get. And then we have to scroll to the other side. Doesn't matter if you're on the red or the blue line, as long as you're on each side of the intersection. So it kind of isolates that area. And then it says guess, and you have to enter one more time to get the intersection point. So you can see that x is -1, y is 2. Well, here we're solving for x. So x is -1 would be the solution. And then, of course, you want to plug that in and check it. So -1 plus 2 is 1. The square root of 1 is 1. 1 plus 1 is 2. All right, does that equal 3 minus -1? 3 minus a -1 is plus 1. 3 plus 1 is 4. The square root of 4 is 2. So that checked out, which means that x equals -1 is the solution. So again, graphing this equation, finding the intersection point, that is definitely going to be the easiest method for you to solve an equation with two radicals. Example 5, solving an equation with a rational exponent. All right, so we're going to solve this very much like a radical equation by isolating the variable with the exponent first. So the first thing I need to do for the first one is subtract 2 on both sides. All right, so I'm going to have 2 raised to the 1/2 power. Remember, that's the same thing as the square root of 2x, anything to the 1/2 power. And then 10 minus 2 is 8. So to get rid of the 1/2 power, I'm going to square both sides. 1/2 of 2, remember, properties of exponents, a power to a power, you multiply exponents. So half of 2 is 1, and that leaves just my 2x on the left. And then 8 squared is 64. Divide both sides by 2. X equals 32. All right, again, you can plug it in and check it. So I'm going to do 2 times 32, that's 64. 64 to the 1/2 power, that's the same thing as square root of 64, that's 8. 8 plus 2 is 10. So again, it's quick and easy to check. Make sure you do that. so you know that it is a real solution and not an extraneous solution. Example 6, solving an equation with a rational exponent. So example 6 is a little bit different. We can see that we have a variable on both sides of our equation. So we're still going to square both sides to get rid of that 1/2 power. Remember, that's the same as a square root. So if I have a power to a power, I multiply. 1/2 of 2 is 1, and that leaves just x plus 30 on the left side. And then x squared is just going to be x squared. All right, I need to subtract x and subtract 30. So subtract x and subtract 30. Move it to the other side. What you do to one side, you have to do the same thing to the other side. So now I'm going to have 0 equals x squared minus x minus 30. Now looking at this, I have a quadratic. That should make you think factoring. So I'm going to have x times x. What multiplies to give me 30? 1 and 30, 3 and 10, 5 and 6. I need 1 in the middle. 5 and 6 are 1 apart. So I'm going to use 5 and 6. I need to multiply to get a negative number, which means I need to have opposite signs. I need one positive and one negative. The bigger number has to be the sign in the middle. So the bigger number has to be negative. So this one's positive. Always check it to make sure. X times x is x squared. Minus 6x plus 5x is negative x. 5 times negative 6 is negative 30. Now we set each factor equal to 0. So x plus 5 equals 0. X minus 6 equals 0. Subtract 5. X equals negative 5. Add 6. X equals 6. So we have two solutions. We need to check to see if they're real solutions. All right, so let's take negative 5. So we're going to take negative 5 and plug it back into the original equation and see if it gives us a true statement. Negative 5 plus 30 is 25. 25 to the 1/2 power, or the square root of 25, is 5. Then I have equals x. X in this case is negative 5. 5 does not equal negative 5. So that means that is that's not a true solution. That one was an extraneous solution, so we can just mark it off. It's not a solution. 6, plug in 6. 6 plus 30 is 36. The square root of 36 is 6. Does that equal 6? It does. That's a true statement. So that means that one is a true solution. So there's only one solution here. X equals 6 is the solution for example 6. Last example, example 7, solving a radical inequality. All right, so we're going to do the same thing with the inequality. We're going to isolate the radical first. So we need to isolate this by dividing by 3. We have 3 times the square root, which means we need to divide to undo the multiplication here. So it's going to leave us with the square root of x minus 1 is less than or equal to 12 divided by 3 is 4. Now we're solving the same way, so we're going to square both sides to get rid of the square root. We're trying to solve for the unknown. The square root and the squared cancel, so that leaves x minus 1 less than or equal to 4 squared is 16. Then I'm going to add 1. X is less than or equal to 17. So the solution for this one is going to be x less than 17. You also have to consider that underneath the radicand is x minus 1. So we know that the variable here, like this, can't be less than 0. So we can say that x also has to be greater than or equal to 1. So 1 minus 1 is 0. And we can't have a negative here. So it has to be at least 0. So stating that x greater than or equal to 1 ensures that. So you can actually turn this around. Let's put the 1 here and the 17 here. And we can write this as a compound inequality. So we know if we flip this around, the sign's going to be like this. And then this one stays the same because the x was already on the left. And this is how you would represent the possible solutions of this inequality. So remember, inequalities have more than one solution. So any numbers between 1 and 17 will work for this radical inequality. You won't see radical inequalities that much, and so it's a little bit different. But just be aware, whatever is under the radical sign, to get this second piece here, whatever's under the radical sign, you can set that equal to 0, and you get that number here. So x minus 1 equals 0, and then add 1 to both sides, and you get 1. So basically, whatever will make that 0, it has to be above that again, just because it's a radical equation. It's a square root equation. All right, that's all for 4.4. If you have any questions, let me know.